All right, so what we're going to do here, we're going to combine section 210 and 211. All right, so this first part comes from section 210. Okay, so I want you to go to section 210, flip to number 2. All right, we're going to talk about verifying solutions. Okay, what all we need to do here, and some of you have probably done in the past when you check for extraneous solutions, we're just going to check to see if this x value actually works. And how we're going to do that is by plugging in the x value into our given equation. So if we look at number 2a, all right, 2a, I have 2 minus 3x equals negative 7. So I want to think of it like this, 2 minus 3, when x is 3, does that equal negative 7? Okay? It says for each of the following, verify the given solution is a solution to the equation by substituting and checking if the true statement yields the results. All right, well, if you look at this, okay, 3 times 3, I get 2 minus 9. Does that equal negative 7? Sometimes your book will put a little question mark over the top because I keep saying, does that equal? And that's what that little question mark is. 2 minus 9, negative 7 equals negative 7, so that checks out. All right. So basically, that's all you do. You just check to make sure that it works. Okay, that's it. All right, so let's plug in 2 for x in this equation. 14 over 2 minus 1, minus 4 equals 10. 14 over 1 minus 4 equals 10. Well, any number over 1 is just that number itself, so it's 14 minus 4, 10. Holy buckets! 10 equals 10. Check. I should have been putting that question mark as I went along. Apologize. It's on B. I'm going to do a little tougher one here. Okay. Excuse me. Where we have to deal with the square root. All right, we have to deal with the square root. So, okay. So if I plug in my 5 into that square root, I get 2 times 5 minus 1 all underneath the square root. Does that equal 8 minus 5? So I have to input this x into both sides, right? I'd say to both sides of our equal sign. That's something new. Okay, well, 2 times 5 is 10 minus 1 square root does that, and then 8 minus 5 is 3. 10 minus 1 is 9. Square root of 9 is 3. For that. Let's plug in negative 2. Negative 2, the opposite of negative 2 squared plus 5 times negative 2 plus 14. Does that equal 0? Well, one thing we got to be careful of, negative 2 squared is actually 4. And then I have to apply the opposite from right here. Very important. I cannot stress this enough, and I continue to say this when we deal with negatives in this class and squaring negative numbers, that you use parentheses if you're inputting that into your calculator, okay? That you're using parentheses. 5 times negative 2 is negative 10, plus 14, does that equal 0? Negative 4, negative 10, that's negative 14 plus 14, so that is 0, and that equals 0, so we win. So negative 2 is a solution. This is all the work that you have to show for that, just to make sure that it is a solution. All right. If this were an assessment, how would we assess you on this? We would say, tell me if this number is a solution or not. Now, will there be a case where it might not be? Yes. And what would that look like? Well, I wish I had the example for you. I think I might have cut that one off. But if we would have gotten something like this, 2 equals 0. That's not true. Therefore, that would not be a solution. If my left and right side did not equal each other, we're not the same number, then I would have no solution, or I would say that this is not a solution. All right, now we're going to flip to 2.11. Okay, so go ahead and flip there. We're going to skip the explore on this section. Okay, I didn't really particularly like the explore on this section. Okay, So we're just going to kind of skip it. All right. So all we're doing, this section is writing equations based on word problems. All right. And we're going to do this in a couple different contexts. We're going to solve it numerically, write it algebraically, solve it algebraically, and then verify it. All right. So example 1, it says that Eli says that he needs $225 more in his account to reach $1,875 necessary for the down payment on a car. All right, so solve this numerically. Eli's account is $225 away from the necessary money. Subtracting $225 gives me $1,650. Notice that we begin to subtract from his goal and subtract $225 to get the current balance. How much money is in account now? All right, so we want to find his current amount of money. He's $225 away. So if I want to reach this number, okay, I'm just going to subtract that. That's what they're saying. All right. Now I could also look at this algebraically. All right. B is his current account balance plus that 225 equals what he wants, his goal, his 1875 goal. And again, what would I be doing? Well, I would be subtracting that 225 from both sides and still get the same answer. Okay. And then I would just plug it back in and verify it. All right. So that's an example given to you. Let's try one. All right. So number 2, you watch a current TV show like Biggest Loser or something that says, the trainer says down 7 pounds in 1 week. The screen behind the contestant shows 168 pounds. What was the weight last week? Well, if my current weight is 168 and I'm down 7 pounds from my previous week, all I'm going to do if I'm solving numerically is add 7 to my current weight to get 175 pounds. Okay, what did I use? I used addition. So if I use addition to solve for my ending number, that means if I want to use the inverse operation of addition to actually solve or write my algebraic equation. And what that means is if I'm adding 7 to that 168, that means my ending number was 168, right? Oops, let me hold on. All right, my ending number was 168. I'm going to let W equal weight. Okay. So what am I going to do? What did I do to the 168 to get 175? I added 7. So that means I'm going to have my current weight minus 7, or excuse me, my previous weight minus 7, give me 168. This weight is really his weight last week. So if I lost 7 pounds last week and I ended at 168, that's kind of how I got this equation. Okay, the weight last week is as W minus 7 gives me 168. Well, obviously to solve this equation, all right, I have W minus 7 equals 168. Well, I want to add 7 to both sides, and look, this matches what we did numerically. Okay, so how do I know my actual algebraic equation was correct? If boxes A and C, the actual work that you're doing, match each other. Okay, what am I doing here? I'm taking 168 and adding 7. What am I doing here? I'm taking 168, adding 7. Look, the actual work itself matches. Okay. Check my work. I just do 175 minus 7. 5 looks like an 8. Does that equal 168? Oh, yes, it does. It checks out. State your answer to the question. His weight last week was 175 pounds. All right. Let's see. I want to be able to do one of these together. All right. So we're going to pause here. So I want to do this one as a whole class. All right. So we're going to pause here. end the video, and then we're going to come back together the whole class.